Okay, the last thing I really have to teach you for this unit, there's another concept which I don't know if I'm going to make a video about because it's basically just an application of what we did in the last video. It's where you would have a function, but then you can kind of substitute a trig value in for x and be able to figure it out. I don't think that I need to cover that though, because it's basically just like an application of what we did in the last video. Just know that you can do that, and yeah, if you guys request a video, I'll do one for that too. But this one we're talking about improper integrals. An improper integral is an integral where it's kind of like a precursor to limits, or not limits, kind of limits, but series. But it's basically an integral like this, but it's from something like 1 to infinity. Now, an integral can't exist from 1 to infinity because the integral is an area underneath something, so theoretically, shouldn't that always be infinity if you're taking the area from something to infinity? Well, actually, in some cases, no. However, you can't just plug in infinity into this because that doesn't mathematically make much sense, so we're going to have to actually use limits. So what we're going to do is we're going to, instead of saying that it's an integral going from 1 to infinity, we're just going to say it's an integral from 1 to a value nearing infinity. And to do that, we're going to use limits. So you'll use a limit, and I'll call mine b. I'll say b is going to infinity, and then 1 to b of 1 over x squared dx. So now what we're going to do is do our normal situation that we would do, except instead of putting in a number for here, we just put in b. So the antiderivative of 1 over x squared. I'm sorry, my phone keeps going off, and I'm waiting for something really important. So, I'm sorry, 1 second. Okay, sorry about that. Okay, I just turned it off, so hopefully that won't happen again. But, the antiderivative, well, this is the same thing as the limit. And it's really annoying, so you have to keep writing out the limit as something. You have to keep the notation up, so don't forget to keep writing limit, integral, all this stuff. But it's the same thing as x minus 2 dx. And so the antiderivative would be adding 1, so it would be x to the negative 1 times negative 1 in the front, or negative 1 over x. So, then what we do is we say that this is the limit from b going into infinity, and then the bracket, negative 1 over x, and then from 1 to b. Don't put infinity into this, because that doesn't make much sense. And you're going to get the limit. Once again, keep rewriting this out. I know it's a pain, but you gotta do it. And then you would have negative 1 over b minus, but because it's negative, it'd be kind of like plus 1 over 1, which would be like 1. And now you're going to plug in infinity because you're doing a limit, and you'd get negative 1 over infinity, which is just going to be 0 plus 1, and that equals 1. So that means that theoretically the integral, if you took the x squared one and you went from 1 to infinity to infinity, you'd actually only end up getting 1. I know it's kind of weird, isn't it? But that's because it's so close to the x-axis that you're adding such little amounts that they actually end up converging to a number. If you end up getting infinity, which is what you would get infinity if it was 1 over x instead of 1 over x squared, you'll find out why in the series unit, but you would get a diverging function, or one that goes to infinity. It's good that you start practicing this vocabulary now, because this is the entire content of the first series unit you'll be doing later. Diverging is if the area goes to infinity and it diverges. Converging means it converges to a number, like here, it converges to 1. So that's improper integrals. I'm debating whether or not I should do the next video, just because, to be honest, I don't really remember it very well, and I think I have to look back into that, so I don't think I'm going to do it right now, because it won't be the best video for you guys. But if you guys want one, just let me know, and I will make one about if you have functions, you can plug in trig values for x and use it to simplify it, and it's a whole trigonometric application. But yeah, other than that, I think we're basically done with this unit.